This is 11.3, solving radical equations. And a radical equation is simply an equation that has a variable in a radicand. And we're going to see lots of examples of those. So let's jump right in. Example 1, solving by isolating the radical. And isolating just means get the radical alone. So we want to solve each equation and then check our answers. So if I'm going to isolate the radical, I just want to know, how can I get this square root of x all by itself? Well, it's the same as if it was just x minus 5. The opposite of minus 5 is to add 5 to both sides, so that we end up with the square root of x is equal to 9. And then how would you get x alone? How do we get rid of this radical? Well, the opposite of square rooting something is to square it. So I'm just simply going to square both sides. The square root of x squared, those cancel, so x equals 81. And so now we've solved, and to check, just plug in 81 into your original equation. So I have the square root of 81 minus 5 equals 4. The square root of 81 is 9, minus 5 equals 4. 9 minus 5 is 4, and 4 equals 4. Therefore, we got the correct answer. So x is 81. Let's try that again on B. So if we're isolating the radical, then in B, we already have isolated the radical. It's all by itself on the left side. So we're going to start by getting rid of the radical by squaring both sides. The opposite of square rooting x minus 5 would be to square it. So anytime you square a radical, they just cancel. So I have x minus 5 equals 4 squared, which is 16. And then how do I solve for x? Add 5 to both sides, and x equals 21. Now again, we need to check. So I have the square root of 21 minus 5 equals 4. 21 minus 5 is 16. The square root of 16 is 4. And that's true, the square root of 16 is 4, and 4 does equal 4. Okay, well, let's look at some of these quick checks. So again, we're solving and then we're checking. So I have the square root of x plus 7. So again, I need to always get the radical by itself before I do any squaring. So to get the square root of x by itself, I just need to subtract 7 from both sides. The square root of x equals 12 minus 7 is 5. And then to get rid of this radical, all we have to do is square both sides. Remember, square rooting and squaring, they're opposites of each other, so they undo each other. So x equals 25. And then to check, just plug it into your original equation. Square root of 25 plus 7 equals 12. The square root of 25 is 5. 5 plus 7 equals 12. That's true. We can stop right there. B, same thing. Isolate your radical. So add 4 to both sides so that the square root of a equals 9. And then the opposite of square rooting is squaring. So square both sides. That cancels, and a equals 81. Plug in 81. The square root of 81 minus 4 equals 5. Square root of 81 is 9. 9 minus 4 does equal 5, so we did it correctly. The answer is 81. Last one on C. So this one was like the B in our original example. So the radical is already isolated, and so we just go ahead and square both sides to get rid of our radical. Squaring and square rooting cancel each other, so we have C minus 2 equals 36. Add 2 to both sides, so that C equals 38. And then to check, just plug it in. So the square root of 38 minus 2 equals 6. 38 minus 2 is 36. The square root of 36 is in fact 6. So our answer is correct. C is 38. Okay, example 2. Here we have a real-world example. The loop on a roller coaster ride has a radius of, and anytime I see numbers, I know that's going to be important. So I'm just going to go ahead and highlight that. A radius of 18 feet. Your car has a velocity of 120 feet per second at the top of the loop. How high, that's what we're trying to find, is the hill you have just come down before going into the loop. So I'm trying to find the height, how high. Then we have this equation. Use the equation v equals 8 times the square root of h minus 2r, where v is the velocity, h is the height, and r is the radius. So we have radius and velocity. We're trying to find height. I'll start with my formula. V equals 8 times the square root of h minus 2r. And then I'll plug in what I know. I know velocity is 120. 120 equals 8 times the square root of, I'm trying to find height, so obviously I don't know it, minus 2 times what's the radius? 18. And now I'll go ahead and simplify since I can do 2 times 18. So I have 120 equals 8 times the square root of h minus 36. And we want to do what we've been doing, which is isolating the radical. So how do I get this radical alone? Well, pretend this is just 8 times x, because it's the same thing. It's 8 times the radical. So the opposite of multiplying would be just to divide both sides by 8. So 120 divided by 8 is 15. So I have 15 equals, these 8's cancel, the square root of h minus 36. And now that our radical is isolated, we want to get rid of it. And to do that, we do the opposite of square rooting, which is to square both sides. So we have 15 squared, which is 225. 225 equals h minus 36, because those canceled again. The opposite of h minus 36 is to add 36 to get h alone. Add 36 to both sides, and we get h equals 261 feet. So the height at the top of the hill is 261 feet. So all you do is take that formula, plug in what you know, isolate your radical, and solve. Okay, example 3, solving with radical expressions on both sides. So here our radicals are already isolated. We just need to get rid of them. So again, the opposite of square rooting is to square. Remember, whatever you do to one side, you have to do to the other, which is great because squaring both sides gets rid of our radicals on both sides. So those radicals and the square rooting and the square, those cancel. So I have 3x minus 4 equals 2x plus 3. Now it becomes a real simple algebra problem. I need all my variables on the same side. So I'm going to subtract 2x from both sides to get all my x's together. 3x minus 2x is x minus 4 equals 3. Then to get x alone, add 7 to both sides. So I have x equals 10. And you can check these as well if you just plug in your your solution into your equation. So here we actually are going to have to check after we solve. So the square root of 3t plus 4 equals the square root of 5t minus 6. Since our radicals are both already isolated, we want to just go ahead and get rid of them by squaring both sides. Square rooting and squaring are opposites. They undo each other. So I have 3t plus 4 equals 5t minus 6. And then simply solve. I want all my t's on the same side, so subtract 3t from both sides. 4 equals 5t minus 3t is 2t minus 6. Add 6 to both sides. 10 equals 2t. Cancel. Divide both sides by 2. And t equals 5. Now they want us to check, so simply plug in 5 into your equation. So I have the square root of 3 times 5 plus 4 equals the square root of 5 times 5 minus 6. So 3 times 5 is 15, plus 4 is 19, so the square root of 19 equals 5 times 5 is 25, minus 6 is 19, so the square root of 19. Does the square root of 19 equal the square root of 19? Certainly it does, so our answer is correct. Okay, we're on to our next to last example here, example 4, where we have to talk about extraneous solutions. So extraneous, that root is extra, and really in this case it just means a solution that does not satisfy the original equation. So you see in these other examples we've been checking, and we always notice that our answer we get, when we plug it back in, it always works. It always, 5 plus 7 does equal 12, 9 minus 4 does equal 5, so it always satisfies our equation when we plug in our solution. Well, we're going to see in these problems that we're about to work that we're going to find more than one solution and not both of them will work. So if we're identifying the extraneous solutions, we're trying to find the ones that don't work. So we have x equals the square root of x plus 12. So our radical is already isolated. We simply need to get rid of it by squaring both sides. So I have x squared equals, now these just cancel, so I have x plus 12. Now I have an x squared, an x, and a 12. So I want to make this look like a trinomial equation, a polynomial equation. So I'm going to move everything to one side. So I'll subtract, actually instead of doing that, I think what I'll do is I'll subtract x and I'll subtract 12 from both sides. So I end up with x squared minus x minus 12 equals 0. I subtracted x from both sides, that's where you get the negative x. Then I subtracted 12 from both sides to get negative 12 equals 0. Now remember, in order to solve an equation like this, you need to factor. So we want to find the factors of the last term, negative 12, that add to the middle term, negative 1. And let's see, factors of negative 12 that add to the negative 1. So I know I need to do a negative times a positive, and the negative needs to be bigger. So 1 and 12, or 1 and negative 12 doesn't work, 2 and negative 6 doesn't work. 3 and negative 4, though, 3 and negative 4, 3 times negative 4 is negative 12. If you add them, you get negative 1. So I'm going to use 3 and negative 4 as my factors. So that's x plus 3 times x minus 4 equals 0. And then to solve, simply split it up. X plus 3 equals 0, or x minus 4 equals 0. Subtract 3 from both sides. So x equals negative 3, or add 4 to both sides, and x equals 4. So remember, we're trying to find the extraneous solution. So that means both of these may not work. So we just need to check and see which one does and which one does not work. So we're going to plug each one in. So I'll start with negative 3. Negative 3, actually let me rewrite my equation for you. X equals the square root of x plus 12. So I'll try negative 3 equals the square root of negative 3 plus 12. Negative 3 equals the square root of negative 3 plus 12 is 9. And negative 3 equals the square root of 9 is 3, or it could be a negative 3. Remember, it's always plus or minus. Negative 3 times negative 3 is 9. Also, 3 times 3 is 9. So negative 3 does work. Let's check 4. So I have 4 equals the square root of 4 plus 12. 4 equals the square root of 16. So 4 equals 4. So 4 works. And really, if we look back at negative 3, the original, the square root of 9, the original solution would just be simply a positive 3. So it actually doesn't work. And that means 4 is the only one that does work. So x equals 4 is our answer, and negative 3 doesn't work. So let me just do a couple more. I know that was a little confusing. So let me just show you this one more. Y equals the square root of y plus 2. So we need to square both sides. Y squared equals the square root of y plus 2 squared. That cancels, so I have y plus 2. I'm sorry, this is y squared. I need to move these both to that side, so I have y squared minus y minus 2 equals 0. Find the factors of negative 2 that add to the negative 1. And so I need a negative times a positive, which is going to be a negative 2 and a positive 1. When you add, get a negative 1. So I have y minus 2 times y plus 1 equals 0. Split them up. Y minus 2 equals 0, or y plus 1 equals 0. Add 2 to both sides. Y equals 2. Or subtract 1 from both sides. Y equals negative 1. And then we have to try both of them. So I have y equals the square root of y plus 2. First we'll try 2. 2 equals the square root of 2 plus 2. 2 equals the square root of 4. 2 does equal 2, so that one works. Let's try negative 1. Negative 1 equals the square root of negative 1 plus 2. Negative 1 equals negative 1 plus 2 is 1, the square root of 1, and negative 1 does not equal 1. The square root of 1 is just 1, so that would mean our extraneous solution is negative 1. It does not work, therefore our only solution is 2 on that one. Okay, we're out of time, so we'll do our last example in the next video.